Our magnificent world, a vibrant tapestry of life, faces a growing challenge. It is a challenge born of our own ingenuity, yet one that now threatens the delicate balance of nature. I'm speaking, of course, of plastic. This versatile material, once hailed as a miracle, now chokes our oceans, litters our landscapes, and infiltrates the very fabric of the living world. For too long, we have followed a linear path: take, make, dispose. This cannot continue if we are to safeguard the future of our shared home and all its wondrous inhabitants. The sheer scale of plastic accumulation demands a radical rethinking of our relationship with waste. We have, for decades, chanted the mantra of the 3 Rs: reduce, reuse, recycle. These principles are noble and indeed essential. They have guided many well-intentioned efforts to lessen our impact. However, as the mountains of discarded plastic continue to grow, it has become painfully clear that these measures alone are insufficient to stem the tide. The complexity of plastic types, the economics of recycling, and the sheer volume of consumption often render these traditional approaches overwhelmed. We find ourselves at a critical juncture, a point where urgent innovation is not just desirable but absolutely necessary for planetary health. Fortunately, human creativity, the same force that brought us plastic, can also forge solutions. From the heart of Africa, a pioneering initiative called Electroplastication, spearheaded by smart Afrogrics, offers a beacon of hope. This is not merely another recycling scheme, it is a transformative process, a bold step towards a truly circular economy where waste is not an endpoint but a valuable beginning. It is a vision where the problem of plastic pollution is ingeniously converted into an opportunity for energy generation, community empowerment, and sustainable development, breathing new life into discarded materials. Imagine a world where the plastic that blights our environment becomes a source of power for communities. Imagine it being used to build durable homes and infrastructure. This is the promise of electroplastication. It is a concept that dares to look beyond the limitations of current systems, offering a comprehensive approach that tackles waste at its source and converts it into tangible benefits. This initiative represents a profound shift in perspective, recognizing that what we discard still holds immense potential, waiting to be unlocked by clever science and compassionate application for the good of both people and planet. The call to reduce, reuse, recycle has echoed for generations, a seemingly straightforward guide to responsible living. Reducing our consumption is undeniably the most impactful first step. If we use less, we generate less waste. This requires a conscious shift in consumer habits and industrial design, moving away from a throwaway culture towards one of durability and mindfulness. Many have embraced this, choosing reusable bags, water bottles, and seeking products with minimal packaging. Yet the pervasive nature of single-use plastics in our global economy presents a formidable obstacle to widespread, impactful reduction across all sectors of society. Reusing items extends their life, delaying their journey to the landfill. This common-sense approach has been practiced for centuries, from repairing clothes to repurposing containers. Creative individuals and communities find ingenious ways to give old objects new purpose, showcasing resourcefulness and a respect for materials. However, the scale of modern production often makes new items cheaper and more convenient than repairing or extensively reusing older ones. Furthermore, many products, particularly plastics, are not designed for multiple life cycles, becoming brittle or unsafe with repeated use, thereby limiting the practical scope of this crucial R. Recycling, the third R, is often perceived as the ultimate solution to our waste woes. The idea of transforming old plastic bottles into new products is certainly appealing. Collection schemes are widespread, and many diligently sort their waste. Yet the reality of plastic recycling is far more complex and sadly often less effective than we might hope. Not all plastics are easily recyclable. Contamination, the mixing of different plastic types, and the presence of food residues can render entire batches unprocessable. The economic viability of recycling also fluctuates wildly, sometimes making it cheaper to produce new virgin plastic than to recycle the old. Consequently, vast quantities of collected plastics, even those placed in recycling bins with the best intentions, end up in landfills or incinerators, or worse, are shipped across an ocean only to become another nation's burden. The infrastructure required for effective, sophisticated recycling is expensive and not universally available. This leads to a significant gap between the amount of plastic collected for recycling and the amount actually transformed into new materials. The traditional 3Rs, while vital components of waste management, clearly need reinforcement with more robust and innovative solutions to truly address the plastic crisis gripping our planet. Out of this pressing need for more effective solutions, a truly innovative concept has emerged: electroplastication. This pioneering initiative, championed by smart Afrogrics, represents a paradigm shift in how we perceive and manage plastic waste. It is not merely an incremental improvement on existing methods, it is a bold leap towards a genuinely circular economy. In such an economy, materials are kept in use for as long as possible, their value retained and regenerated at the end of their service life rather than being discarded. Electroplastication embodies this ideal by transforming problematic plastic waste into valuable resources, primarily electricity and construction materials. The term electroplastication itself hints at the transformative power at its core, using energy in part to fundamentally alter the state of plastic. Unlike traditional recycling, which often struggles with mixed or contaminated plastics, this process is designed to handle a wider array of plastic types, reducing the need for meticulous sorting that often plagues conventional recycling efforts. It aims to break down the complex polymer chains of plastics into simpler, more useful components. This approach moves beyond simply melting and remolding. It delves deeper into the chemical nature of plastic to unlock its stored energy and material potential in a more comprehensive way. The vision of smart Afrogrics is to create a closed-loop system where the environmental burden of plastic waste is converted into social and economic benefits. This is particularly crucial in regions where access to reliable electricity and affordable housing is limited. By siting these electroplastication facilities strategically, the initiative can directly address energy poverty while simultaneously tackling local pollution. It is a system designed for resilience and local empowerment, turning a global problem into a source of local strength and self-sufficiency, fostering a healthier environment for communities that need it most. This approach redefines waste itself. In the context of electroplastication, discarded plastic is no longer seen as refused to be managed or hidden away, but as a feedstock, a raw material brimming with potential. This inherent shift in perspective is fundamental to building a sustainable future. It encourages us to see value where previously we only saw a problem. Electroplastication, therefore, is more than just a technology. It is a philosophy that champions resourcefulness and innovation, offering a tangible pathway to lessen our environmental footprint while improving human well-being across the globe. The journey of plastic waste through the smart Afrogrics electroplastication system is a fascinating example of applied science. It begins with the collection of diverse plastic materials, often unsorted and representing the challenging reality of municipal waste streams. Once gathered, this plastic feedstock is prepared for the first crucial stage, pyrolysis. Pyrolysis is a thermochemical decomposition process where materials are heated to high temperatures in an oxygen-starved environment. This anoxic condition is critical as it prevents combustion, meaning the plastic doesn't simply burn and release harmful pollutants into the atmosphere as it would in uncontrolled incineration. Instead, the intense heat systematically breaks down the long, complex polymer chains that constitute plastics. These chains, which give plastics their durability and versatility, are deconstructed into smaller, simpler molecules. The primary products of this pyrolysis stage are typically a mixture of hydrocarbon gases, a liquid oil-like substance known as pyrolysis oil, and a solid residue called char. Each of these components has potential value. The careful control of temperature, pressure, and processing time during pyrolysis is essential to optimize the yield and quality of these intermediate products, ensuring maximum efficiency in the subsequent stages of the electroplastication journey. Following pyrolysis, the generated hydrocarbon gases and vaporized components undergo further refinement. This stage often involves a process of carefully controlled vaporization and fractional distillation if necessary to separate the different components based on their boiling points. The goal is to isolate a clean, combustible gas stream that can be used efficiently for energy generation. Any contaminants or impurities that could hinder the subsequent power generation or lead to undesirable emissions are meticulously removed or treated during this phase. This ensures that the fuel fed to the power generation unit is of a high quality, maximizing energy output and minimizing environmental impact. This intricate preparation of the fuel stream is vital for the longevity and efficiency of the power generation equipment. Smart Afrogrics has invested in ensuring that this conversion from solid plastic to a usable gas is as clean and complete as possible. The system is designed to handle the variability inherent in plastic waste, adapting the process parameters to accommodate different types and conditions of feedstock. This robust design is key to the practical application of electroplastication in real-world settings, where waste streams are rarely uniform, making the technology both versatile and resilient. Section 5. Harnessing the hidden power, carbon capture and turbine dynamics. Once the plastic waste has been successfully converted into a clean, combustible gas through pyrolysis and subsequent purification, the next stage in the smart Afrogric system is the generation of electricity. This is where the stored chemical energy within the plastic is finally unleashed. The purified gas, rich in energy, is directed into a combustion chamber. Here, it is mixed with air and ignited under controlled conditions. This combustion process releases a significant amount of thermal energy, producing hot, high-pressure gases. This is a critical transformation, converting the chemical potential of the waste into kinetic and thermal energy ready for work. A particularly ingenious aspect of the smart Afrogrics design is the integration of carbon absorption or capture technologies. Before the hot exhaust gases from the combustion process are vented, they can be passed through systems designed to capture carbon dioxide or CO2, a primary greenhouse gas, while the initial fuel is derived from plastics, which are fossil fuel products, minimizing the atmospheric release of CO2 from the energy generation step itself is a key environmental consideration. This captured carbon can then potentially be sequestered or utilized in other industrial processes, further enhancing the overall sustainability of the electroplastication system and reducing its carbon footprint. The high-pressure, high-temperature gases produced by the combustion of the syngas are then channeled to drive turbines. These turbines are precision-engineered devices, much like those found in jet engines or conventional power plants. As the hot gases expand and rush past the turbine blades, they cause the turbine shaft to rotate at high speed. This rotational mechanical energy is the crucial link between the thermal energy of combustion and the generation of electrical power. The efficiency of these turbines is paramount to maximizing the electricity output from a given amount of plastic-derived fuel. Finally, this rotating turbine shaft is connected to a generator. Inside the generator, the mechanical energy of the spinning shaft is converted into electrical energy through the principle of electromagnetic induction. This electricity can then be fed into a local grid, providing power to homes, schools, businesses, and clinics in communities that may have previously lacked reliable access to such a vital resource. Thus, the problematic plastic waste completes its remarkable journey, transformed from a pollutant into a source of light, warmth, and opportunity, powering progress where it is most needed. Section 6. A community effort, Smart Afrogrics Waste Collection Revolution. The success of any waste-to-energy initiative, like electroplastication, hinges critically on a consistent and reliable supply of feedstock, in this case, plastic waste. Smart Afrogrics has addressed this challenge with an innovative and community-centric approach to waste collection. They are implementing a system that not only gathers the necessary plastic, but also incentivizes participation and provides direct economic benefits to local populations. This is achieved through strategically placed waste ATMs, automated kiosks where individuals and informal waste collectors can deposit their collected plastic waste, making the process accessible and rewarding. These waste ATMs are designed to be user-friendly. Upon depositing plastic, the machine weighs the material and, based on a predetermined value, credits the depositor. This transaction is often facilitated through a digital currency system such as OCOM. This digital currency can then be used by community members to pay for essential goods and services, including electricity generated by the electroplastication plant itself, or it can be exchanged for conventional currency. This creates a direct link between waste collection efforts and tangible economic reward. empowering individuals and fostering a sense of ownership over the local environment. The use of a digital currency like a coin offers several advantages. It can promote financial inclusion in communities where access to traditional banking services may be limited. It provides a transparent and secure method of transaction, reducing the risks associated with handling cash. Furthermore, it allows smart Afrogrics to track the flow of plastic waste, gather valuable data on collection rates, and potentially identify hotspots of plastic accumulation. This data-driven approach can help optimize collection routes and outreach programs, making the entire system more efficient and responsive to community needs and waste generations patterns. This smart collection system does more than just supply the electroplastication plants. It transforms the perception of waste within the community. Plastic litter, once seen merely as an eyesore or a nuisance, becomes a resource with discernible monetary value. This encourages widespread participation in cleanup efforts, leading to cleaner streets, healthier local ecosystems, and a reduction in plastic leakage into waterways. It formalizes the role of informal waste pickers, often a marginalized group, providing them with a safer, more dignified, and more profitable way to earn a living, thereby integrating social upliftment directly into the operational model. Section 7, From Waste to Wonder, Building with Recycled Plastics. The ingenuity of the smart Afrogrics Electroplastication initiative does not end with the generation of electricity. Even after the pyrolysis process, there can be residual plastic materials or the char byproduct that may not be suitable for energy conversion but still possess valuable properties. Instead of discarding these remnants, smart Afrogrics envisions a secondary life for them in the construction sector. These materials can be ingeniously repurposed to create durable and sustainable building components, such as bricks, paving slabs, and even elements for larger structures, showcasing a truly holistic approach to waste valorization. One of the most exciting applications is the creation of plastic bricks or composite blocks. These are often made by mixing the residual plastics, sometimes with other aggregates like sand or the char from pyrolysis, and then melting and molding them into uniform shapes. These bricks can be remarkably strong, lightweight, and possess excellent insulating properties. Furthermore, Smart Afrogrics is exploring the use of 3D printing technology to create customized building components from these recycled plastic composites. This allows for intricate designs, rapid prototyping, and on-demand production of construction elements tailored to specific needs. The use of these plastic-derived construction materials offers significant environmental and economic benefits. They provide a productive outlet for plastics that might otherwise be difficult to recycle through conventional means, thus diverting more waste from landfills. The resulting building materials are often highly durable and waterproof. This resilience makes them particularly suitable for construction in areas prone to harsh weather conditions or humidity, offering longevity where traditional materials might degrade more quickly. Their lightweight nature can also reduce transportation costs and simplify the construction process itself. By transforming residual plastics into valuable construction materials, Smart Afrogrics is not only closing the loop on plastic waste, but also contributing to affordable and sustainable housing and infrastructure. This is especially impactful in vulnerable communities where access to quality building materials can be a significant challenge. The ability to produce these materials locally can reduce reliance on expensive imports and create new employment opportunities in manufacturing and construction, further strengthening the local economy and enhancing community resilience through innovative resource management. Section 8. The Ripple Effect. Empowering lives and healing ecosystems. The impact of Smart Afrogrics Electroplastication initiative extends far beyond the technical processes of waste conversion and energy generation. It creates a powerful ripple effect, touching lives and healing ecosystems in profound ways. One of its most immediate and significant social impacts is the provision of clean, reliable electricity to vulnerable communities. In many parts of the world, access to electricity is a luxury, not a given. Its absence hampers education, limits healthcare, stifles economic activity, and diminishes overall quality of life. By generating power locally from an abundant waste resource, electroplastication can illuminate homes, power schools, and support local businesses. This newfound energy independence can be transformative. Children can study after dark, clinics can refrigerate essential medicines, and small enterprises can operate more efficiently, creating jobs and boosting local economies. The smart waste collection system, with its OCO digital currency, further empowers individuals by providing a direct financial incentive for environmental stewardship. It offers a dignified income stream, particularly for those in the informal waste sector, improving livelihoods and fostering a sense of community pride. This economic empowerment, coupled with a cleaner local environment, contributes to improved health outcomes and social well-being. The environmental benefits are equally compelling. By diverting vast quantities of plastic waste from landfills and unregulated dump sites, electroplastication directly tackles a major source of pollution. This reduces the contamination of soil and water sources, protecting local biodiversity. The prevention of plastic from entering rivers and eventually the ocean is crucial for marine ecosystems, which are currently suffocating under the deluge of plastic debris. Furthermore, the controlled process within an electroplastication plant is designed to be far cleaner than uncontrolled burning of waste, which releases harmful dioxins and furans into the atmosphere. Moreover, the creation of durable construction materials from residual plastics offers a sustainable alternative to conventional resource extraction. This lessens the demand for virgin materials like timber, clay, or cement, the production of which often carries a significant environmental footprint through deforestation, quarrying, and high energy consumption. By using waste as a resource, smart Afrogrics not only cleans up existing pollution, but also helps to conserve natural resources for future generations, embodying a truly circular and regenerative approach to development that benefits both people and the planet they depend upon. Section 9. A future forged anew, the promise of electroplastication. As we stand at this crucial moment in our planet's history facing unprecedented environmental challenges, initiatives like electroplastication by smart Afrogrics offer more than just a solution, they offer hope. They demonstrate that human ingenuity, when guided by a commitment to sustainability and social equity, can turn our most pressing problems into opportunities for profound and positive change. The traditional model of dealing with waste is clearly broken, and the limitations of simply reducing, reusing, and recycling, while important, are insufficient to cope with the scale of the plastic pandemic that afflicts our world today. Electroplastication represents a transformative leap forward. It is a holistic system that redefines waste as a valuable resource, converting problematic plastics into essential electricity and durable building materials. This process not only mitigates pollution, but actively generates economic and social benefits, particularly for marginalized communities. The ingenious smart waste collection system, utilizing ATMs and digital currency like a coin, empowers individuals, fosters community participation, and creates a tangible link between environmental responsibility and economic well-being, making every citizen a stakeholder in a cleaner future. The ripple effects are far-reaching. By providing reliable energy, electroplastication can unlock human potential, improve education and healthcare, and stimulate local economies. By transforming residual plastics into construction materials, it offers sustainable solutions for housing and infrastructure, reducing reliance on virgin resources and building more resilient communities. This is the essence of a circular economy in action. A system where materials are kept in use, value is preserved, and nature is respected, creating a harmonious cycle of production and regeneration, rather than a destructive linear path. The journey of electroplastication, from a concept to a functioning reality, showcases a pathway toward a more sustainable and equitable world. It is a testament to the power of innovation to address complex global challenges. As we look to the future, it is clear that solutions like those pioneered by smart Afrogrics will be essential in forging a new relationship with our planet, one based on stewardship, resourcefulness, and a shared commitment to the well-being of all its inhabitants. The promise of electroplastication is the promise of a cleaner, brighter, and more just tomorrow for generations